You said recently tens of billions of robots, but that's decades away.
At least 1 decade away.
It's got to be more than that.
It's going to grow very fast.
Why do you think that?
I think humanoid robots will be the biggest product ever. The demand will be insatiable.
You said that.
Everyone's going to want one. It's like, basically, who wouldn't want their own personal C-3PO R2-D2?
No,
everyone's
right. You've said that, and your goal. You've also said is to produce 1 million robots. I think by 2030. That's what I had you on the record as saying.
I think that's a reasonable target.
And then start towards sustainable abundance, which you can get into. But I wonder. We've been talking about autonomous and how long it takes to train the automobile to be able to be the equivalent of or exceed human capabilities. But what about these robots, to the extent that how much training are they going to need to actually to be able to do various different types of tasks? Isn't that something that's going to take a long time? Yeah.
It's just going to take a lot of compute resources, and it'll take time. I think there's certain threshold breakthroughs that we think we can achieve, where if Optimus can watch videos, YouTube videos or how-to videos or whatever, and based on that video, just like a human can, learn how to do that thing, then you really have task extensibility that is dramatic. Because then it can learn anything very quickly. So I think we'll get there in the next.
We're not there yet, though.
We're not there yet.
You're relying on a significant uptick in terms of learning and training.
Yeah, no, that's why I'm calling it a very significant threshold. Would be
understood
the ability to learn from watching a video.
Right.
But at the point
as opposed to watching a human, right? Or having a human sort of train it right now with a task.
I mean. Right now, we're training Optimus to do like primitive tasks where a human in a kind of what's called a mocap suit is and sort of cameras on the head is moving in the way that the robot would move to, say, pick up an object or open a door, or the basic tasks: throw a ball, dance. And we need to I think that's needed to sort of bootstrap the intelligence so you can have the basic functions. Then where I think it gets very interesting and very much like humans is that you want the robot to self-play. Right. So you say, how does a child learn? Well, a child has toys, and a child plays with the toys, plays with the blocks, at some point figures out how to put the triangle in the triangle hole and the circle in the circle hole. By doing it over and over again, and this self-play. Once you have a lot of robots, you can do this self-play, which is that you just put the robot in a room with toys, and have the robot literally have the robot play with toys,
and it will learn.
Yeah, and you have to have a reward function. Say like, okay, the goal of the robot is to put that classic child's toy. You put the circle in the circle hole, the square in the square hole, triangle in the triangle hole, and keep doing it until it works. And the reward function is succeeding.
And there are no advances needed to accomplish that now? I mean, no advances in AI or just compute and things of that nature that can happen?
There are some advances needed, but I don't think these are insurmountable. I think we can solve these things in the next few years. So the new Optimus 22 degree of freedom hand and forearm is now in production, and it's learning to walk and catch balls. It's pretty cool. I mean, look at that's where we came from. It's wild. So in a very short period of time, Optimus has gone from being an idea to the most sophisticated humanoid robot on Earth. There's nothing even close to the level of sophistication of Optimus, and Tesla has some important missing ingredients that others don't have, which is our robot has a real brain. It's like the Wizard of Oz, Tin Man. Well, was that a heart or a brain? One of the two. So it's got the real world AI. So Tesla's the leader in real world AI. What we learned in the car, we translate to the Optimus robot, and we also take our expertise in electric motors, in batteries, power electronics, structural design. And then another major important thing is that we're very good at manufacturing. So in order for robots to be useful, they have to be intelligent. They have to be able to do useful things just by asking, and you have to be able to make a large number of them at an affordable price. This is what we can do. We have the only company with all the ingredients for making intelligent humanoid robots at scale is Tesla. This is a super big deal. Like my prediction is that on this front is that Optimus will be the biggest product of all time by far. Nothing will even be close. I think it'll be 10 times bigger than the next biggest product ever made. Like that level. So this year we hopefully will be able to make about 5,000 Optimus robots. We're technically we're aiming for enough parts to make 10,000, maybe 12,000. But since it's a totally new product with totally new, like everything is totally new, I'll say like we're succeeding if we get to half of the 10,000 now. But even 5,000 robots, that's the size of a Roman legion, FYI, which is like a little scary thought, like a whole legion of robots. So I'd be like, whoa, yeah. But I think we'll literally build a legion, or at least one legion of robots this year. And then probably 10 legions next year. And I don't know, it's kind of a cool unit, units of legion. So probably 50,000-ish next year. And then it's probably ready I'm hopefully ready for Optimus to be used outside of Tesla controlled environment, or maybe around the middle of next year, second half of next year sometime. So that's, I think, that sounds about right. Probably second half of next year is when they'll be available. And then we will offer Optimus robots first to Tesla employees. So it's pretty wild to just, be in Palo Alto with a bunch of cubes and then a humanoid robot just walks past. We've made a massive amount of progress with Optimus in a short period of time, from someone pretending to be a robot dancing in a suit to a pretty hodgepodgey robot to a robot that is actually doing useful tasks in the factory today. So we have 2 Optimus robots in our Fremont factory that are doing basically this task, which is taking cells off the end of the line and placing them in a shipping container. And yeah, we actually have quite a few of these cruising around our offices in Palo Alto. So and I think we've got one major hardware revision, which should be done by end of this year or early next, and then we'll move into a limited production next year of Optimus. Limited production for use in our factories, where we'll test out the product, eat our own dog food or whatever the electronic equivalent of that is. So, but I think like next year, my prediction is next year we'll have over 1,000, maybe a few thousand Optimus robots working at Tesla. And things are going to scale up very rapidly from there. So we'll iron out the bugs. It'll like the degree of autonomy will be radically better. You'll just literally be able to talk to it and say, please do this task, or I'm going to show you something. Now do the thing that I'm showing you. And get to the point where it can watch a video of something like a person and then learn just by looking at that video and do that task. So yeah, so really it's going to be quite something. And I'm confident of the prediction that there will be more, like the ratio of humanoid robots to humans will be greater than 1-to-1. Tesla is going to be by far the leader in that. You're seeing a lot of robot startups, but I think it's actually very challenging to do Optimus as a robot startup, because what we found, to make Optimus work, we've had to design from first principles, from scratch, every part of the robot. So the motor, the gearbox, the power electronics, the communication system, everything had to be done from scratch. We found that there's basically nothing. There's no supply chain. So even though there are many electric motors made in the world, there's no supply chain for the types of motors and sensors and gearboxes that are needed for a humanoid robot. And what you're seeing here is our current generation hand and arm, but our next which has 11 degrees of freedom. Our next generation has 22 degrees of freedom. It will be able to play the piano. So it's really like, wow. Now, of course, like I said, we need to make sure we don't have the Terminator scenario. That's very important. So, safety of the humanoid robot will be very important. But because it requires so much ground-up designing every motor, gearbox, sensor, power electronics from scratch, it's very hard for a startup to, if not impossible, for a startup to replicate that. But at Tesla, we have the world's best electrical engineering. I think we've got the world's best mechanical engineering for gearboxes and for electric motors, power electronics. We have the resources to do that. It applies quite well. And then you also have to have the brain. You need you need a power efficient inference computer, which we've got for the car, and we'll be using an Optimus. You need AI, you need to be the best in real world AI, and Tesla's the best in real world AI. So you need all of these, you need a very strong hand of cards in order to make a compelling robot. And then you also need to be very good at scale manufacturing. So in order to have the robot not cost like hundreds of thousands of dollars, in order to make it cost like $10,000 or $20,000, you actually need to design for manufacturing and be very good at manufacturing. In my experience, prototypes are easy compared to volume manufacturing. Prototypes are easy, production is hard, relatively speaking. So Tesla has the production capability, it has the engineering capability, and it has the AI hardware and software capability. And even the most optimistic estimates that I've seen for Optimus, the Optimist, I think undercount the magnitude of what this robot will be able to do. As I said at the beginning of the presentation, I agree with the ARK Invest analysis that autonomous transport is called sort of a $5 to $7 trillion market cap situation. Optimus, I think, is a literally $25 trillion market cap situation. So I think with Tesla and the real-time video coming from the several million cars, ultimately tens of millions of cars, with Optimus, there might be hundreds of millions of Optimus robots, maybe billions, learning a tremendous amount from the real world. That's the biggest source of data, I think, ultimately is sort of Optimus. Optimus is going to be the biggest source of data
because
reality scales. Reality scales to the scale of reality. It's actually humbling to see how little data humans have actually been able to accumulate. Really, if you say how many trillions of usable tokens have humans generated, where on a non-duplicative, like discounting spam and repetitive stuff, it's not a huge number. You run out pretty quickly.
And Optimus can go, so Tesla cars unfortunately have to stay on the road. Optimus robot can go anywhere. There's more reality off the road and go off road.
I mean, like the Optimus robot can like pick up the cup and see, did it pick up the cup in the right way? Did it, say pour water in the cup, did the water go in the cup or not go in the cup? Did it spill water or not?
Yeah.
Simple stuff like that. I mean, but it can do that at scale times a billion, So generate useful data from reality. So cause and effect stuff.
What do you think it takes to get to mass production of humanoid robots like that?
It's the same as cars, really. I mean, global capacity for vehicles is about 100 million a year. And it could be higher. It's just that the demand is on the order of 100 million a year. And then there's roughly 2 billion vehicles that are in use in some way. So, which makes sense. Like the life of a vehicle is about 20 years. So at steady state, you can have 100 million vehicles produced a year with a 2 billion vehicle fleet, roughly. Now for humanoid robots, the utility is much greater. So my guess is humanoid robots are more like at a billion plus per year.
But, until you came along and started building Optimus, it was thought to be an extremely difficult problem. I mean, it is an extremely difficult problem.
So walk in the park. I mean, Optimus currently would struggle to walk in the park. I mean, it can walk in a park. Park is not too difficult, but it will be able to walk over a wide range of terrain.
Yeah, and pick up objects.
Yeah. It can already do that.
But like all kinds of objects.
Yeah.
All foreign objects. I mean, pouring water in a cup is not trivial. Because then if you don't know anything about the container, it could be all kinds of containers.
Yeah, there's going to be an immense amount of engineering just going into the hand.
Yeah.
The hand might be close to half of all the engineering in Optimus. From an electromechanical standpoint, the hand is probably roughly half of the engineering.
But so much of the intelligence of humans goes into what we do with our hands.
Yeah.
There's the manipulation of the world, manipulation of objects in the world, intelligent, safe manipulation of objects in the world. Yeah.
Yeah. I mean, you start really thinking about your hand and how it works.
I do it all the time.
The sensory and control homunculus is we have humongous hands.
Yeah.
So, I mean, like your hands, the actuators, the muscles of your hand are almost overwhelmingly in your forearm. Mm-hmm. So your forearm has the muscles that actually control your hand. There's a few small muscles in the hand itself, but your hand is really like a skeleton meat puppet, and with cables. So the muscles that control your fingers are in your forearm, and they go through the carpal tunnel, which is that you've got a little collection of bones and a tiny tunnel that these cables, the tendons, go through, and those tendons are mostly what moves your hands.
And something like those tendons has to be re-engineered into the Optimus in order to do all that kind of stuff.
Yeah, so like the current Optimus, we tried putting the actuators in the hand itself. Then you sort of end up having these like
giant hands.
Yeah, giant hands that look weird.
Yeah.
And then they don't actually have enough degrees of freedom or enough strength. Mm-hmm. So then you realize, oh, okay, that's why you got to put the actuators in the forearm, and just like a human, you got to run cables through a narrow tunnel to operate the fingers. And then there's also a reason for not having all the fingers the same length. So it wouldn't be expensive from an energy or evolutionary standpoint to have all your fingers be the same length. So why not they're the same length?
Yeah, why not?
Because it's actually better to have different lengths.
So as you're figuring out this problem, you have to also figure out a way to do it so you can mass manufacture it, so as to be as simple as possible.
It's actually going to be quite complicated. The as possible part is it's quite a high bar. If you want to have a humanoid robot that can do things that a human can do, it's a very high bar. So our new arm has 22 degrees of freedom instead of 11, and has the actuators in the forearm. And these all the actuators are designed from scratch, from physics first principles. The sensors are all designed from scratch, and we'll continue to put a tremendous amount of engineering effort into improving the hand. Like the hand, by hand I mean like the entire forearm from elbow forward. Mm-hmm. Is really the hand. So that's incredibly difficult engineering, actually. And so the simplest possible version of a humanoid robot that can do even most, perhaps not all, of what a human can do is actually still very complicated. It's not simple. It's very difficult.
I think the thing perhaps most notable is if you look at the difference between the last time we showed Optimus, and this is a video that was taken basically yesterday, and the Optimus team was up all night making this video. The Optimus team has done an incredible job. So just, yeah. And it's the motors, controllers, the electronics, and everything you see in the Optimus robot is a Tesla-designed system. So this is, we actually tried to find drive actuators and whatnot that were off the shelf. We found that there weren't any. In order to make an effective humanoid robot, you actually have to design the motors and gearboxes and the electronics from scratch, because it's a very different application from anything else that exists. So we took our world-class motor and power electronics team and said, okay, we need to design several actuators that don't exist in the world, and they did. So Optimus is working quite well. And then for full self-driving, as full self-driving gets closer and closer to generalized real-world AI, that same software is transferable to a humanoid robot. Just like humans can obviously walk around with their arms and legs, but we can drive a car, fly a plane, steer a boat, ride a horse. If you have a generalized understanding, or if you have generalized real-world AI, which is what we are developing for full self-driving, it can be transferred to basically anything. So Optimus will use the same FSD computer as the car. The Optimus stuff is I think extremely underrated, because people just cannot comprehend the consequences. Now, obviously, we need to make sure that we don't have a Terminator scenario. That's very important. It's all fun and games until Terminator shows up. If you have had a generalized humanoid robot, what would be the effective ratio of humanoid robots to humans? Because I think basically everyone would want one, and maybe people would want more than one, which means the actual demand for something like Optimus, if it really works, I don't know. I mean, 10 billion units. It's some crazy number. It might be 20 billion units if the ratio is say 2 to 1 on people. Humanoid robots versus people. It might actually be. It's some very big number, is what I'm saying, and a number vastly in excess of the number of cars. So my prediction is that Tesla's long-term value will be a majority of the long-term value will be Optimus, and that prediction I'm very confident of.